Okay, let's look at the basics of chemical formulas. Sometimes we overlook so much we actually don't see what we need to see. Now this shows me what I would call a formula unit. In other words, the pattern that exists in that formula. And it shows me the elements involved and the number of elements involved and the total number of elements engaged in the formula unit itself. So that begs the question, what is a formula? We've already seen that elements have a shorthand thing called a symbol. So we know that a compound is a group of elements that's been bonded together in a fixed ratio. So what we can see is that this is a shorthand for a compound. Now the shorthand for compound must use the symbols of the elements involved. And it should also show me the number of elements involved, the ratio, if you like, of the elements being bonded together. And this is the key to understanding the whole idea of formulas. So let's look at this example. We can see that we've got capital letters and numbers, and that is typical for most formula. So the capital letter here and the capital letter here tell me I've got two different elements. So you always look for the capital letters to start off with. So we look at this one, and from the periodic table we can see that this C is for carbon, and because the element is there, or the symbol is there, it says we've got one of them. If there were more carbons present, then we would see a number here, just behind carbon, and notice it's a subscript, so it always sits below. Now, to work out how many elements we've got, we look at the number of capital letters we've got. In this case, we've got two capital letters, so that means I've got two different elements, and then we'll tell me I've got one of this, and over here we've got the fact that we've got two O's below it. So we've got a total of 1 plus 2, or 3 atoms in each molecule or formula unit of carbon dioxide. And that basically is a simple way of looking at formulas. So let's delve a bit deeper and have a look at some other ones. This structure here is called sodium hydrogen carbonate, or sometimes we refer to it as sodium bicarbonate. Now, capital letters, 1, 2, 3, 4. How many different elements? 4. Right, Na is for sodium. Don't get confused, sodium is not S. S is sulfur. Sodium's Na. Then next element I've got is H. H stands for hydrogen. Then I've got C for carbon, and I've got O for oxygen. So let's look at how many of each one have I got. I've got one sodium combining with one hydrogen, combining with one carbon, combining with 3 oxygens. So I've got 1, 2, 3 plus 3 makes 6 atoms per formula unit, and the ratio of putting them together is 1 to 1 to 1 to 3. Alright, so no matter how complex our structure gets, we just follow those simple rules. So let's look at the next one. This material is actually part of the clay family, and it's called kaolinite. And we can see that there are 1, 2, 3, 4, 5. But hold on, that and that are the same one. So really we've got 1, 2, 3, 4 different elements in this. And I'd like you to find out, or to tell me, the ratio, the number of each element that go into making up this structure. So take your time and do it. So if we then look at this answers to it, we've got Al, capital A, that's an L, that's aluminium. Si, silicon. O, oxygen. But hold on, there's some more oxygens there, more about that later. And H for hydrogen. So we know that this compound is made from aluminium, silicon, oxygen and hydrogen bonded together. We know there are 2 aluminiums. We know there are 2 silicons. We know there is 5 plus 4 or 9 oxygens. And we know there are 4 H's. So that gives me 2 to 2 to 5 plus 4 to 9 to 4 is our ratio of the atoms we would mix together to make this structure. I hope that makes it simple, and I hope that makes it easy to understand. More about this later.